Good morning and good evening to everyone, and thank you for joining Lightbend and AWS. I'm Kim Sherman. I've got a couple of housekeeping items I want to go over. One, the session is being recorded, so feel free to leave if you don't wish to be part of a recorded session. We will have a link to this webinar available on Monday, July 26th. Second, we will leave time for a question and answer session. Use the Q&A panel to submit questions, and we will answer as many as possible before the end of the webinar. And if we don't get to yours, you are welcome to send your questions to partners@lightbend.com. Now, without further ado, I'd like to introduce Hugh McKee. He's developer advocate at Lightbend, and Mahant Jayadeva. He is with AWS, and he's a solutions architect. Mahant, let me turn it over to you.
Awesome. Thanks, Kim. Good day, folks. Thanks for joining us today. So to start off with, the session is called How to Develop Well-Architected Microservices with Akka. But let's talk a little bit about well-architected. So when you look at the systems that you and your teams are building and designing, can you answer the question, are you well-architected? Hopefully, most of us would say yes. After all, we have some great people working in our teams. So I encourage you to start thinking about this question. Now, what happens is that confidence often drops as you consider each of these different topics. You might feel that there are some topics that you want to dive deeper in. So, for example, you might feel that you could have better performance from your workloads, or you could be better cost optimized, and that will let you pass on this savings to your end customers. So, how can we increase that confidence level? How can we ensure that if somebody were to ask you, are you well architected, you can answer that confidently? One way you could do that is by having a pre-launch review process. So this will give you and your teams an idea of what was done and why it was done as you begin to roll out your new software, new product, whatever it is. The challenge with that, though, is these review processes might not always be consistent. Different people have different skill sets. They have different experiences. So they might ask different questions to understand what's going on with this workload. The other thing is it's quite rare to be able to answer that question across your entire technology portfolio. You might have a limited view of what's going on within your workloads, but can you answer that confidently across your entire technology portfolio? So that's sort of where well-architected comes into the picture. Well-architected is something that AWS came up with almost a decade ago. We're going to talk a little bit about that today and how it can help you feel more confident about answering that question, are you well-architected? So first things first, you might all be wondering, well, why do I even need this? What's in it for me? So well-architected has several, at least high-level benefits that it offers. So it helps you build and deploy faster. So by reducing firefighting, by reducing capacity management, and by using automation, you can experiment and release value more often. So you no longer have to have those quarterly deployment cycles and things like that, where if something goes wrong, you have to roll back the entire thing. So agility is the name of the game, and automation is something that is very common. It's a very common theme across all of well-architected, and you're going to see that as you start exploring well-architected a little bit more. The next one is it helps you lower or mitigate risks. So it helps you understand where you have risks in your architecture, and it helps you address them before they actually impact your business and distract your teams. Because your teams are made up with very skilled, very talented people that should be working on adding value to your business, creating new features, new functionality. That's the sort of stuff, that's the value add that you're looking for. If they're having to deal with these risks that exist within the architecture, now that's additional distraction that's preventing them from doing the things that they're extremely good at. The next one is it helps you make informed decisions. So a well-architected review is a very data-driven exercise. It is not based on somebody's opinion, somebody's experiences, somebody's thoughts. It's a very data-driven exercise. So it ensures you've made active architectural decisions and how they might impact your business outcomes. And the last one is it helps you learn AWS best practices. And these are, it helps ensure that both you and your teams are aware of all the best practices that we ourselves as AWS have learned to reviewing tens of thousands of customer workloads on AWS. So we've seen this time and time again, and we've seen customers be very successful with it, and we want to pass that on to you as well. So let's talk a little bit about what the actual framework is. So the well-architected framework provides a set of questions and design principles across 5 different pillars. So the hierarchy is from left to right in this on this slide here. So we have 5 different pillars. Based on each pillar, we have a set of design principles, and based on those design principles, we have 1 or more questions. The 5 different pillars we have within AWS well architected is operational excellence, security, reliability, performance efficiency, and cost optimization. The way I'd encourage you to think about this is creating technology solutions is a lot like constructing a physical building, right? If the foundation is not solid, it may cause structural problems, and these structural problems could undermine the integrity and function of the building. Similarly, if you neglect these 5 pillars when architecting technology solutions, it can become a challenge to build a system that delivers functional requirements and meets your expectations. So that's where you want to really sort of think about all these different pillars and see how you're going to incorporate these pillars and realize the benefit that they have to offer, which will help you produce very stable and efficient systems, allowing you and your teams to focus on functional requirements and adding value to your business. Next, we have design principles. So we have design principles across all 5 pillars. We also have general design principles. The key distinction here is general design principles apply across all workloads at a very high level. Pillar-specific design principles takes those general design principles and talks about how that would reflect if applied specifically to the topic covered by that pillar. So an example here is automate responses to security events, right? So that is a very pillar-specific design principle that is in the security pillar. Now, automating responses to all events is something that we should ideally be doing so that you have that very event-driven situation. And that's an overarching design principle that's applicable across all pillars, whether it's cost, reliability, operational excellence, whatever it is, it's applicable to all workloads across all 5 pillars. Design principles help you adopt the appropriate mental model when building for the cloud. So it helps ensure that you're taking advantage of all the capabilities of AWS and free yourself from the constraints of traditional approaches that you might have had to take in a data center, for example. Next, based on those design principles, we have 1 or more questions. This is an example. This is a little screenshot from the actual framework itself. As you can see here, we started off with the pillar area. We have different pillar areas for each pillar. And that's just a logical grouping of questions that address the same sort of topic within that pillar. So in this situation, it's change management, right? Then we have the question itself. One thing you might notice is the questions are intentionally phrased to be open-ended. The intent behind that is to start a conversation about your approach. This is not an audit. This is not about placing blame. The questions serve as a prompt for you and your team to start talking about, well, how in this situation, how do we monitor our workload resources? Do we monitor all the aspects of it that gives us the right insights that we're looking for? We also have a little bit of question context that helps you understand what the question is referring to. And then it's followed by a list of best practices. So these are things that you can implement within your own workloads to have that very solid positive outcome you're looking for. To learn more about the AWS well-architected framework, you can go check out that link. We have white papers for the actual framework itself. We have pillar-specific white papers. We also have well-architected lenses. So there are we have a plethora of white papers for you to go through. Lots of amazing information. Again, it's sourced from a wide variety of people and not just a couple of individuals here and there. For anybody who's not a fan of reading long PDF documents, we also have the same content available in a very modular web-based format. So you can go to wa.aws.amazon.com. And a little trick is, once you're on the page, if you click on the AWS well-architected logo on the top right-hand corner, it opens up that graph that you see in the middle panel here. And that gives you a very quick way of being able to jump around different pillars, different questions, different sections. And then the actual content itself gives you the question, the best practices, and also gives you a lot of resources on how to implement those best practices. So it's a very guided way of improving your workloads. If you would like to learn more about AWS Well Architected, we offer free training. So you can go to that link there, and I'm guessing Kim is going to share these slides out with you after the session. So you'll have these links available. So you can go to that training. It's self-paced, so you can, and it's all modular, so you can spend as much or as little time as you want on the different sections. We also have well-architected labs. This is by far one of our most popular content assets, if you will. These are self-paced, hands-on labs that walk you through implementations of all the best practices within well-architected. It gives you a step-by-step guidance of how you could achieve a certain outcome, and it helps you understand all the different services that can potentially go into implementing that. So definitely check these out as well. Awesome. So now we've talked a little bit about well architected. Hugh, do you want to walk us through how well architected and Lightbend sort of work together?
Yeah, thanks, Mahant. And it's really interesting. I'll admit I'm new to the well architect. I've spent the last few weeks really diving into it. And I was delighted to see the overlap of some of the things that we've been evangelizing at Lightbend with the things that you guys have been evangelizing for a decade. I think we've both been doing this, like how to go to the cloud and do it well. So what I'd like to do is walk through the 5 pillars and look at the different design principles in these 5 pillars, each one of them, and kind of emphasize areas that I think what we contribute to with the Akka platform. So for example, starting out with the first pillar, I'm just going to go in order with the operational excellence pillar. These are I took the design principles from the framework documentation, and I've highlighted 2 of them that I think we really contribute to. You know, there's things like perform operations as code, which is more, the day-to-day running of the systems, deployments, and things like that, which, we're providing tools to build systems, not the tools, to say operate the system. So I'm not going to focus on that. But these 2 areas that make frequent, small, reversible changes, we really try to contribute the technology to enable you to do that. And then anticipate failure is, that's in our DNA at Lightbend, is building systems that run robustly in the cloud. So those 2 I definitely want to highlight. So to kind of go through that, I kind of want to walk through kind of an evolutionary path from monolith to microservices, and kind of some of the intermediate stages that we see in how people do this. So I've got kind of 4 stages here. So the first one is where there's the monolith, but I'm kind of emphasizing that it's not just the code that is involved, it's also the data. So I'm kind of treating both, covering both here as far as how these things can change as you really start to embrace some of the concepts in the well-architected framework, as well as in the technologies that we provide. So often what we see when people first move in to do things with microservices is that they'll break up the code, which is cool. It's a great start. And you're moving from that monolithic approach to doing things where you've broken up the code. Maybe you've done domain-driven design to identify the microservice you want to do, but now you've done some. You got your start. Now the database hasn't changed. Often it's a lot easier to get permission, I guess, from management and everybody that that is involved with this to start to your first initial steps into microservices at the code level, but it's often much more challenging to break up, say, a legacy monolithic database. I'm also showing the microservices here kind of tightly grouped together, and this has to do with coupling, and I'll be talking about coupling quite a bit, because here it's kind of a next evolutionary step. where the microservices themselves are more loosely coupled versus tightly coupled. And I was delighted to see how much emphasis there was on coupling in the well-architected framework, because this is something we've been talking about a lot as well. But there's this term microlith, and I'll define what that is in a minute, but it's still kind of a microlith, and primarily because you still have a monolithic database. So often what we see is that when people move into microservices, they'll go through a couple of generations, architectural generations, and they ultimately start to arrive at something like this, where you've not only broken up the code, but you've broken up the data. So what's a microlith? A microlith is, it's kind of a, we're playing with the term here, and we've been using it. I don't know who coined the term. I know the first time I heard it was when Jonas Benera, who's the CEO of our company and the creator of one of the key creators of the Akka framework, the Akka toolset, was using the term in some of his communications. But it's a distributed monolith. So you're doing some microservices, and I'm not saying this is a bad architecture in any case, but it's just kind of pointing out that you're still kind of thinking monolithically, even if you're doing microservices, and also that you typically have a monolithic database. So this comes into coupling, and where the microservices themselves are tightly coupled because they're communicating with each other like they're making procedure calls, but they're remote procedure calls, and they're doing, you're doing things restfully and so on. And there's great tools to do this, and we can do it really well. So again, I'm not saying this is a bad architecture. I'm just saying that it is one architectural pattern, but there are other architectural patterns to consider as well. So to kind of show a bit of coupling, I'm just going to walk through quickly here a scenario where, say I have a client on this little phone device on the left. It sends in some kind of request like add item to shopping cart to microservice A. But for microservice A to do its work, it needs to ask microservice B to do something for it, maybe check something or whatever. So microservice B gets a request from A, and then B, in order for it to do its work, it needs to talk to microservice C. So now C gets the request from B. So the client is waiting for A is waiting for B is waiting for C finishes its work. It sends its response back to B finishes its work, it sends a response back to A, and then finally we go back to the client. This is a pretty typical scenario, tightly coupled, synchronous, kind of RESTful remote procedure call kind of an approach. The question is, this comes in with the failure, considering failure. And I always like to emphasize, don't use the word if something breaks, use the word when something breaks or something fails, face failure head on. So what do we do when something fails here? Well, a worst case scenario is C's broken. We can't talk to, B can't talk to C. So either B has to have some kind of mitigating response when it can't talk to C to send back to A, or B fails. So the failure cascades from C to B, the failure can cascade from B to A, and then the failure goes out to the client and says something didn't work, please try again later, which is really annoying. We've all seen this in the apps that we've used, and it's not a nice user experience. Here's another pattern where, say, there's a bunch of microservices in each of these little boxes, but there's this microservice in the center labeled C, and say this is customer data. So when all these other services need customer data, no problem, you just make a RESTful request to C, everything's good, get the response back, and these microservices can do their work. Easy to implement, easy to get running into production. But when C fails, what does that mean? Well, it could mean that the blast area for the problem here could be quite large. Like all these other microservices are broken or failing because they can't do their job unless they can talk to C. Not a good place to be. So it's kind of like you're back with a monolith. If the monolith goes down, you're down. Well, when you're building microliths, kind of tightly coupled using this approach, you're vulnerable to this. So the alternative to tight coupling is loose coupling. And here's one approach for doing loose coupling using this customer scenario. So you're kind of flipping things on its head. So now we still have all the microservices, but the change is that when C makes a change, say to a customer profile, it just publishes that change out to, say, some topic on some message bus. And the other microservices are listening to that topic. And what they're doing is they're receiving those changes and they're keeping their own view of customer. I know this is, might hurt to think about at first, like we're replicating data, we're synchronizing and all these different things, but the goal, this is becoming more and more of a common pattern, because the goal is that you're trying to break the coupling between that important customer service with everybody else. So now all these other microservices have everything the goal is that they have everything they need to do their job, and they have as little dependency outside of themselves to do their job. So when C goes down, again, when, not if, but when C goes down, none of these other microservices care. They can continue to do their work because they don't have that synchronous dependency to do their work with C anymore. So that's kind of introducing loose coupling, but we still have a microlith because we still have that monolithic database. So the idea is that the goal is really here is that you to try and do things asynchronously. Stop doing make asynchronous the go-to approach, and synchronous RESTful types of things the exception. Flip your architectural design pattern around. Embrace loose coupling. Seriously embrace loose coupling. But the other one is that each microservice owns its own schema. I didn't say database. I'm saying schema. That so what the data looks like is private to each microservice. So there's this idea of a perspective, that microservices have a personality or perspective on the outside. What does this microservice look like? It's got APIs. It's a consumer from certain topics. It's a producer to certain topics, but that's it. That's what the microservice looks like on the outside. On the inside, it's private. So what the data looks like on the inside of the microservice is private to the microservice. The only way to the data of a given microservice, say, is either through what it's publishing through topics or through its APIs. That's it. So this inside-outside view of things, and you are breaking up not only the code but the data itself. So each microservice is kind of this black box or green box. It's just this container, and it's got a well-defined outside view of things, and the inside is hidden behind this behind this facade. So these are the tools that we're trying, that we provide with Akka to build microservices, to do these kinds of things, so that it enables you to, with loose coupling, I think is so important, not only from a production standpoint, but from a development standpoint, where you can make changes really, really quickly. And, the other design principle here, anticipate failure. I like saying embrace failure. In the cloud, you should always be asking, all right, you have some kind of design, architectural design, and you ask the question, I always say, throw rocks at that design. When this breaks, what's the system going to do? And constantly challenge yourself to do that. The fun part is when you build the systems that are robust like this, and you've anticipated failure from the very beginning, things just work in production without a lot of grief and suffering, which is what I really like. So jumping into the next pillar, the security pillar, we don't really, with Lightbend, that's not our area of expertise. So the idea is that in this little diagram here, I'm just showing, like a 6 microservices, these little funky diagrams, and I'll show what this is in a minute. But the idea is that we use things, we depend on other things for security. And it's a safe bet to depend on the kind, the levels of security that you get with, the tools and services that are available in Amazon, for example. So in effect, what we're doing is we put a shield, Amazon security and other tools for security put a shield around the microservices. We have external dependencies for authentication, for authorization, those types of things. So we work with them, but that's not our focus. But reliability is a big one for us. Automatic recovery from failure is huge for us, and scale. So we've been talking about reactive systems for, I think it was since like 2014 when we were the ones behind the reactive manifesto. Many of you may have heard of that. And we were talking about reactive before reactive was cool. It's not just reactive programming, but it's reactive systems. And this really comes into play right here with the well-architected framework. That these are the design principles: automatic recovery from failures, automatic scale, or ease of scaling. And then I think a big one is stop guessing about capacity. So I wanted to show you a demo of what I mean by this. So this is a demo microservice that I wrote that's running in Amazon. It's running in Amazon Elastic Kubernetes Service, EKS. And it's a representation of the anatomy of a single microservice. So all these funky circles, I'm going to turn off some of these lines to kind of clear things up a little bit. So these circles represent kind of the anatomy. So the big circles represent nodes in a cluster. And these are nodes in an Akka cluster. So there's some, consider the terminology. So in Kubernetes terms, these are pods. Pods run containers, one or more containers, and containers run processes like Java virtual machines. So here we have 3 pods that are running 3 containers, and each of those containers is running a Java virtual machine. But these 3 Java virtual machines are running Akka, and Akka forms itself into a cluster. So there's kind of a tightly bound clusters. And then kind of this little tree coming off of each of these kind of root nodes is things running within that JVM. So I'm going to jump to the perimeter. On the perimeter, these little blue circles represent entities, and they are live entities. This demo visualizes the entities that are currently running in this demo application, because you can see them kind of coming and going, and that's kind of a behavior of things that I won't dive into details of that. But each of these entities has some kind of an ID. So this is a generic application, but these entities are things like it could be a shopping cart. So say I'm currently actively adding items to a shopping cart. I'm buying. So one of these entities would be for me, and it's the state of my shopping cart. And if you're doing the same, you would have another one of these entities. So what's happening is your client is directly talking to one of these entities. So right now, there's about 85 or 90 of these things running. And then these green circles represent what are called shards, and they're actually software concepts. And what they're used is to distribute workload across the cluster. So one of the things I can demonstrate with this is I can kind of put a laser pointer on a group of these entities, and they turn red. And what I'm going to do is stop this node. It can kind of trigger a failure. So I'm going to kill this guy. And what you'll see pretty quickly is this is happening at the Akka level, where that shard and its associated entity actors popped up in one of the other nodes remaining in the cluster. So this is the idea that's happening with things that are happening inside of the JVMs, inside of the Akka system, where these entities used to be running on a node that doesn't exist anymore, but they popped up again because there's still customers talking to it. Now, what just happened though is behind the scenes, Kubernetes saw that, hey, this microservice said it wants to run in 3 pods. It lost a pod, so it brought a pod back up. So that was Kubernetes doing its thing behind the scenes here. And then these shards then saw that there was more capacity on the system, so they kind of migrate over. All this is happening kind of beneath the covers within Akka. All we write, as I'll show you later on, we don't focus on any of the mechanics here as developers, but you're getting all this kind of capability, and there's this great symbiotic relationship between things happening inside of the JVMs with Akka, working in conjunction with things happening at the JVM level, at the pod level with Kubernetes. This is the best thing that ever happened in Akka cluster was Kubernetes. So one thing I want to show you is routing of traffic. So I can turn on and off the routing. So you can see there's HTTP requests kind of coming in from a load balancer, the top right, coming to one of these nodes in the cluster. Each one of these nodes, is listening on an HTTP port. And then these what's happening, this is kind of incoming requests from the edge, and then those requests then are being forwarded on to individual specific entity actors. So it's actually showing live, the traffic that's happening in this system right now. So you can see the lines are kind of moving around, and things are happening. So again, if I were to kill another pod, for example, I'll pick on this one again, and you can see that there were messages going to those entities, and now that entity went away, but messages keep flowing to that entity, but those entities are restarted somewhere else in the cluster. So that's an example of dealing with failures. Now another thing is that I can scale up to kind of show want to scale up more traffic, and these are just using Kubernetes commands. And I'm going to scale up the cluster. So this is I'm kind of simulating. All right, there's a spike in traffic. So you can see on the top right, there's more things generating traffic. We went from 5 to 8. So now the number of the entity count, which is down on the bottom left here, it used to be around 80, 85 or something. Now it's around 115. And then you can see new pods coming into the cluster. We went from 3 to 4, and in a moment we should probably see 5. There it comes. So, and then this is where these shards come into play. They see, oh, hey, there's, Akka basically sees, oh, I got more capacity. I'm going to rebalance the load across this cluster. So this is scaling up, and it's with Kubernetes you can auto scale, which is awesome. And then with EKS, the keyword being elastic, you can scale up and scale down the whole entire Kubernetes cluster. So you've got auto scaling at kind of the service level, the microservice level, doing things like auto scaling pods, but you've got scaling at the Kubernetes level using EKS, where you're kind of scaling up and down the environment based on the overall load in the entire environment. Now, just really quickly, I want to show you another demo built exactly the same way. This is an Akka microservice demo, but it's at a much higher scale. And I'm going to zoom in. I'm going to show you. This has almost 250,000 entities running right now. This is an IoT type of a demo. I wrote this demo myself. I wrote both these demos, using Akka microservices. But I wrote this one to do things at scale. So this in this demo, it's sorry. Let me get off. Yeah, the Zoom. In this demo, we're running 100 entities. In this demo, we're running 250,000. We can scale up. So the idea is that this is a Google Map-like type of demo where you can zoom into a part of the world and you can create entities. So in this case, the entities would be simulated IoT devices, and these IoT devices have some kind of a state, like either it's a happy state, a green state, or a red, sad state, or red state. So very basic, but the point is to do things at scale. So, and one of the things I can do with this demo is I can create devices. So I'll show you what's kind of going on here. At the top left, it shows kind of a zoom level on the map. It also has this thing called device density, which means that how many devices would be affected by an operation in this user interface given this current zoom level. And then it shows the current longitude and latitude. And then the top right has kind of a little menu of commands, C for create, D for delete, and happy set type of thing. And a rate limiter. I can change the rate, how much data is fed to the microservice per second. It's set to 1,000 right now. So I'm gonna, just as a quick demo, I'm gonna create, say, 1,000 devices. So I can zoom into a part of the map. I type the C command, I zoom into a part of the map. If I click, then what should happen here is you can see it created those 1,024 devices just now. And what happened was there's two microservices, and one microservice is kind of simulating the outside, simulating devices, but it fed another microservice 1,024 requests, individual requests, each for one entity to say, hey, create a device, and quite a bit of other activity happened. And all that went on, behind the scenes in this microservice. And then just to one last, I'm going to create 4,000 devices here. Just push my luck in a live demo. So it filled up, but it didn't fill up one region. I don't know why, but so now there's, it created 3,000 devices. So there you go. So the idea is this is running at scale. So it's just, I couldn't do this crop circle with 250,000 circles and lines on it. The browser would just go, freak out and not work too well. So that's kind of yeah, go ahead.
One thing I wanted to call out though, when you showed us the crop circle demo, the one thing that I think is interesting is that there is minimal impact to the end user when a failure happens, right? So we commonly have seen systems that are developed where there is some level of automated recovery that happens, which is awesome in itself. But then that usually results in some impact to the end user. So in this case, you were referring to it, the analogy used was a shopping cart. So if I'm a consumer and I'm trying to purchase goods, and I have a bunch of things in my shopping cart, and let's say that entity or that pod were to go down, now all that gets lost, and I'd have to add all those things back again, which makes for a very frustrating experience. But the fact that Akka maintains that state and then remaps it immediately helps me as an end user continue using it. And I think that's really, really key to highlight here.
Yeah, yeah, and of course, there's other ways to maintain the state of a shopping cart. Mm-hmm. But like say though, the trick is to try and minimize the interruption that users would see. And even losing the shopping cart would really be annoying, right? I'd be done. I'm never shopping here again, type of thing. But almost equally annoying is, oh, it didn't work, and try again, type of thing. And and you try again and again and again, and then you get annoyed and go, oh, I'm done. I'm not shopping here anymore. Yeah. And it's also those kinds of things that we're trying to address. Like, regardless of what's going on behind the scenes, embrace failure. It's going to happen. Have a solid plan for dealing with it. This is why I love Akka. This is what drew me to it when I first came to know about it.
Yeah, lots of benefits from a reliability perspective.
Yeah,
and it's all built in. So if somebody's using Akka, it's all this is natively available, right? Yeah. Like they don't have to go figure out an architecture that satisfies their needs and then build it. So it's already available for them.
Yes, absolutely. And it's really embracing the cloud, which is, I think, is so key to this. Mm-hmm. So that's kind of reviewing the design principles of reliability. That automatic recovery is what we were just talking about. It's so key, and it's just kind of baked into the DNA of how we do things at the code level, all the way down deep into AWS, right? Taking advantage of the elastic nature of AWS, the elastic nature of how AWS enables or does Kubernetes into the code, so it's level by level by level. You're taking advantage of that, as well as scaling. That the kind of the elegant automatic scaling up as the load goes up and scaling down, which gets back to, I think, one big thing with the cloud, which is you're really getting to the point where you don't have to worry about capacity, because historically, I remember working on teams where they would ask you, well, how much capacity do you need? And I go, oh man, I got to figure that out again. And you would guess, right? But you had to over provision to handle your spikes. And so the majority of the time you had all this excess capacity that you're paying for, but you're not using. You only use it occasionally when you have those spikes. And even in the cloud, I've talked to people from Amazon, people from Google, that it's the same thing, that you have to over provision just cloud servers when you're not really embracing it. And I love this one about stopgassing capacity, because when you truly have scale and failure, when you solve the failure recovery, you almost kind of solving the scale problem as well. So it's marvelous.
Yep.
So next pillar is the performance one, and here I kind of just said, yeah, well, okay, tick 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 tick, cover them all. And so I just want to point out a little bit about how we do that. And one of the things that we really try to make easy for people to do is to go to event-oriented types of approaches. Really embrace event-oriented. And the idea, one of the kind of fundamental ideas, and this is I like to say, build a system where you do the least amount of work while someone or something is waiting. And I think Amazon is legendary for this with their study about the impact of response time on revenue. This was some years back. I can't remember the exact article, but there was some metrics that were published that said, like, for every millisecond of response time, it costs so much money, lost revenue type of thing. So I think you guys led the way of showing, do the least amount of work because you want to respond as quickly as possible to the user. So one trick to do that is to put off as much other work as possible while not making the user wait for it. So push it out of band is what I'm saying. So and this is what it is really nice about an event-oriented type of system, because with an event-oriented type of system, say you got all these client devices, and you think of them as they're just streaming in a series of commands, like add item to cart, add another item to a cart, change the quantity of the item 2 in the cart, add a third item to the cart, remove the first item to the cart, and so on and so forth. Whatever the application is doing, but each one of those are commands which are intends to perform a state-changing type of operation of a given entity. You're changing the state of a shopping cart, for example. So these commands go into command handlers, and that's what those blue circles were in that crop circle demo. That's where the business logic is at. The command comes in, it's an intent to perform a state change operation. The business logic kicks in, the validation logic kicks in. Is this given the current state of the thing, the entity, can this command be performed? When everything's good, what's emitted are events, and it's persisted. But this is a very highly efficient operation because it's insert only, and and what you're creating is a historical fact. An event is a historical fact, something that's happened, and it's very much like an accounting journal. You don't update something, you don't delete something, you just add things. And any adjustment is just another entry into the journal. This is, I think, has so many advantages. One of them is that it's a very rich source of data. Data scientists, I think, love this kind of data because they're is interested in what I've heard it called negative data. Why did somebody remove an item from a shopping cart? In a traditional CRUD system, that data might not be available, but in an event-oriented type of system, all the data, all the history of what led up to shopping carts, or operations that were completed, operations that were abandoned, it's all there. So it's a very powerful pattern, and it's great for doing the back end out of band type of operation. So that's what I'm going to show here next. Is that, and this is built into Akka itself, where the idea is that there are event handlers that are implemented that are taking those events as they're being created out of band from the user request. And as quickly as possible, they're processing those things. And I've got 3 examples of how they're processed. So one event handler is saying, taking events and pushing them out to some topic in a message bus. Another event handler is taking those events and pushing that data into some kind of queryable table, because this journal is not very queryable. So this is CQRS, Command Query Responsibility Segregation, with event handling. Event sourcing is called. And then the third event handler, say, is taking the same events as well, but in this case is pushing them out to some external API or whatever. But a big advantage of this is things like one of the areas was flexibility. And Say, for example, you implemented this microservices in production, and all of a sudden you realize, oh, we need some more capabilities to do queries. Maybe we we have some queries now that we're doing with a relational database, but it'd be great if we could do, say, some Elasticsearch type of inverted index document type of a database. Well, you can add that. You would be adding another event handler. Since the journal has all of its history, you implement that event handler. You turn it on. It it starts at the very beginning of time. It starts recovering everything, and it excuse me, and it fills up the new table. So it's it's adding in that level of flexibility. So and also things like adding another query operation, observability, experiment, and democratize advanced technology, meaning make advanced technologies available to more people. And I love this one, mechanical sympathy. I had to actually look it up when I saw it in the design principles in the framework, and I looked it up how you've got it defined, and the definition of mechanical sympathy, that the analogy that was used was you don't have to be an engineer to be a racing driver, but you have to have mechanical sympathy. And this was Jackie Stewart, a famous racing driver. And the statement is, when you understand a system, how a system is designed to be used, you can align your design to gain operational performance. And this, I think, is the biggest challenge for going to the cloud. And I know, I knew you and I talked about this, is like we see people going to the cloud all the time, but they're not fully embracing what they can do. And it actually is frustrating, right? It's just like, oh, man, you guys could do so much more with the cloud and really take advantage of it, but you gotta, you change the way you do things.
Yeah, and that's exactly the sort of point of behind well-architected and all these design principles, right? Like we want users to think about AWS and the cloud in a very different way than they did with a traditional data center. So, you don't have to always keep using the same relational database management systems. Like, no, there are other types of databases that could be more appropriate for the type of work you're doing. So instead of having to figure out how to set up your own NoSQL cluster in your data center, just use DynamoDB. It's already there. It's ready for you to use. So really understand, what they're trying to do and use the right tool to be able to do that, and not just treat AWS as a glorified data center, really. Yeah,
and even things like, I know what you guys are doing where the databases are going serverless, right? That it's like a no-brainer to use a database. There's actually like no operational overhead for using it. It's totally serverless, which is, I love it. Right? Less drama, setting systems up. So last pillar, cost optimization. And I just highlighted a couple, adopt a consumption model, measure overall efficiency, and stop spending money on undifferentiated heavy lifting, which is kind of what we were just talking about. Don't have the, I think the idea is that having your people spend more of their time innovating their systems and less of the time enabling those systems, and I see that as heavy lifting, like having to deal with databases, having to deal with networks, having to deal with systems. All these things can be basically go away and allow all that brain power that you have to focus on innovating your applications, which I think is so important. So enable you to do that on top of what you get with AWS. We have now what's called the Akka Cloud platform on the AWS marketplace. So in addition to being able to use the open source Akka to build these things, on top of that, you're getting things like Lightbend Academy, which is training for using Lightbend technology. You're getting telemetry, which is performance monitoring specifically for Akka. So it's adding more performance data to the mountain of data that you get from Amazon as well. And then there's basic operator support that comes with it. So it's a service that we're providing. You can check out, you can find the marketplace page. There's some documentation on the Lightbend site. And then we also have a platform guide that is a very comprehensive tutorial. It includes a lot of information, but there's a tutorial in it that walks you through an iterative development process of creating a set of Akka microservices, walking through multiple stages of the development life cycle, and deploying these things to Amazon, to EKS and Amazon, a Kubernetes environment in Amazon. So it's all documented. I did a 5-part webinar series on this, walking through this platform guide, and it's very, very comprehensive and one of the best pieces of documentation I think that we've produced at Lightbend. So one last thing I want to cover is just a quick pattern. So there's a lot of technology here that we covered. It looks like a lot of things happening, but from a development standpoint, there's like 5 areas that I have to develop, focus on when I'm developing like these demos or working with customers, and any of you that are developers would focus on. It's pretty straightforward. You write the code to handle things coming in, what I call over the edge, like handling incoming HTTP or gRPC requests. You write the code that takes those things and then sends messages to entities. But the routing of those messages across the cluster is not our concern. The routing is handled by Akka. So the next part, and this is really the heart of the microservices, right? Implementing the entity, but that's the the business logic, the validation logic for processing the commands coming into the entities. So that's the second part. Here's a third part, which is one of those event handlers, specifically taking the events that are being created by the entities and projecting them into queryable views. And then another one is just consuming data from topics in some kind of a message bus, and and say treating those as commands that are being fed into entities. And the final one here is just having another type of event handler that's taking those events and say pushing them out to some kind of a message bus. The point I'm trying to make here is that there's a lot of things happening within Akka itself that like the routing and the error, failure recovery, scaling up and down. That that's not what we have to worry about as developers. We focus on the important part, which is kind of the brains of the microservice and the things that only we know how to do, and delegate everything else off to Akka and to AWS. So that was the kind of a quick overview of the cost optimization. So I think that leads us into the Q&A.
Yes, it does. So there are, by the way, there are a couple of questions in the queue that I think are going to warrant a longer explanation than what we can provide on this event. So I just want to let the couple of people know that we will get back to you on that. But Hugh, you shared with me that you had a question you really, really wanted to ask. I'm going to start with you.
Yeah, and so like I said in the beginning, I'm new to the well-architected framework, but I wanted to ask, like, what's the big impact that you've seen with customers that are using it? It's been around for a long time, and it's so comprehensive. I'll say that I was pouring through the documentation, and it's just amazing how much really good stuff is in there. And I was, like I said, I was so delighted to see how much alignment there was with this. A lot of stuff that we try to evangelize, but it was like, wow, this is crazy, but like, what impact do you see?
Oh, I can go on for days and talk about how customers have had success with it. Like some very popular names like Cox Automotive, for example, they've really taken well architected to heart, and they've had great success with it. There's another customer who I cannot name, unfortunately, but this is an interesting story. So they did a well-architected review. They used a well-architected framework, did a well-architected review. There were only a couple of risks that were identified, and they said, okay, I think we're good to go. But then they looked at applying the serverless lens. So we also have lenses which extend the guidance of the well-architected framework. So they applied the serverless lens, and they looked at the best practices specifically for serverless architectures. And they said, this could potentially work They built out a POC. It seemed to work well, and they were happy with it. They deployed it into production. I kid you not, a month later, that same customer called their account team here at AWS, and they were furious. They were like, "What's going on? Like, are you guys trying to be funny? Is this a joke? Like, what the hell?" And the account team was very confused. They were like, "What are you talking about? What happened?" And the customer explained that they got their bill recently, and they said that it's missing a bunch of zeros, and the account team is confused. So everybody's scrambling around trying to understand what's happening. But once they sort of got to the bottom of it, this workload that cost that customer $25,000 a month to run with the architecture that they had, when they refactored it to be a serverless application, that went down to under $250 a month. So they were shell-shocked to really see that this happened just by following a few best practices. And we have lots of stories like this, but this is really something that always, kind of catches attention, because it wasn't necessarily any risks that were within their workloads, but they still went a step forward and said, "Hey, how can we improve this?" So they went from traditional EC2 to serverless, and yeah, they had amazing benefits to the point where they religiously use well architected, and it's embedded in that organization's DNA. So a lot of successful impact using well architected.
Awesome. I'm going to remember that story.
Yeah, when I heard that, I initially thought, hey, I don't think that's right. That doesn't really make sense. But I actually spent a little time digging into it to see what changes they made. And yeah, they really were spending $25,000 a month, and it dropped down to under $250.
Wow, that's incredible.
It is amazing. So one of the questions that came up, Hugh, is that it's a great presentation, and they're wondering if there's like GitHub examples of this microservice architecture.
Yes, I will augment. I'll put the links in this Q&A session to the GitHub projects. There's actually 4 GitHub repos for the 2 demos. All the JavaScript, and it's written in Java, but the front end, the eye candy piece is written in. I wrote it in JavaScript. I'll put the links into the GitHub projects, and I'm trying to document them as so there's lots of documentation. But if you run into questions or something like that, I'd be delighted to try and help out.
Okay, and it looks like let's see here. Any POC example of Java, AWS, and Akka? Not exactly sure what that might mean.
There's actually a number of sources. So the Akka platform guide, definitely a very comprehensive document for that. It's like a POC, I think, because it's a non-trivial application. It's a shopping cart application, but there's actually 3 microservices there. It's available in Java or Scala. Also, my demos are of Akka microservices deployed to Amazon using Kubernetes, EKS and all that good stuff. So those are not, certainly the where on earth when I call it the map demo is a kind of a non-trivial demo, and you can run it at scale. You can put a pretty heavy load on it. So there's that.
Okay, well, we are at the top of the hour, unfortunately. There are more questions in the queue, so when we send out a follow-up to this webinar, I will have an FAQ included in that email, so please look for that email to see answers to these questions. I want to thank everybody who has joined us, and want to remind you that Hugh actually developed a 5-part developer series called Build Cloud Native Microservices. It's being done on Kubernetes and AWS. So that's available. You can go to Lightbend to find that class. We also have classes in Academy that can get you creating apps in a matter of hours, literally. And you can also start using Akka Cloud Platform on AWS. So look for us on the AWS Marketplace. We'd like to thank you again for joining us, and have a good day or evening. Goodbye.